Hey everyone. If you've ever found yourself staring at a terminal screen at 2 a.m., just completely exhausted, trying to figure out why your deployment crashed, well, you are in the exact right place. Today, we're taking that total nightmare of late-night debugging and transforming it into a fully autonomous workflow. We're talking about building a system that doesn't just ping you on Slack when something breaks, but actually rolls up its sleeves and fixes it.
So what if your code could actually fix itself? I mean, it's the ultimate dream, right? Every developer, SRE, DevOps engineer, we've spent years automating our tests and our deployments, but up until now, when that pipeline inevitably failed, an actual human being had to drop everything to go figure out why. Well, today, we are looking at an architecture that flips that entire paradigm completely on its head.
This source material for today's explainer puts it pretty bluntly. Stop manually debugging your code. And, that isn't just some catchy slogan. It's the literal core mission of what we're breaking down today. We're going to see exactly how you can leverage AI to automatically detect, analyze, and totally resolve those incredibly frustrating CI/CD pipeline failures. We're talking about real, tangible relief from broken builds.
Now, what's really interesting about this slide is the sheer contrast between the old way and the new way. It's literally night and day. With traditional DevOps, a pipeline fails, and what do? You manually scroll through hundreds of lines of logs looking for that one stack trace. You write a patch, manually create a pull request, run the pipeline all over again. It's exhausting. But in AI DevOps, the system automatically spots the failure, sends the context over to an AI, and just generates the fix for you. Boom.
Here is our roadmap for today. We'll start with the manual debugging nightmare, cover the self-healing tech stack, see how catching pipeline failures automatically works, look at AI analysis and fix generation, and finish up with deploying the automated fix.
Section 1. The manual debugging nightmare and the problem with traditional CI/CD.
Now, as robust as our traditional CI/CD pipelines are, let's be honest, they're essentially just tripwires. They're great at screaming that something is broken, but the actual heavy lifting of solving the problem still lands squarely on your shoulders. So to fix this, we need a self-healing CI/CD pipeline, basically a workflow that leverages AI to automatically detect, analyze, and resolve pipeline failures without any human intervention. And to be clear, we are not just talking about a helpful chatbot giving you suggestions. We are talking about a totally autonomous loop that reads the error, writes the code, and pushes the solution.
Okay, let's dive into this next part. Section 2. The self-healing tech stack, the arsenal.
So to build this autonomous pipeline, you can't just throw AI at a server and cross your fingers. You need a very specific arsenal where every single tool has an isolated responsibility. First up, we've got GitHub, acting as our version control and pipeline runner via GitHub Actions. Then we have OpenAI, functioning as the brain, right? It analyzes the logs and writes the code. But the absolute critical piece in the middle here is N8N. You've got to think of N8N as the central nervous system. It's securely orchestrating that seamless flow of information between GitHub and OpenAI.
Moving on to Section 3, catching pipeline failures automatically. The trigger. Let's see how this tech stack actually works out in the wild. Picture this. A developer pushes a new feature to the repo, and without knowing it, they introduce a tiny little bug into the system. Here's exactly how it plays out chronologically. The codebase, let's say it's a Node.js and Express app, gets built by the pipeline. Immediately after that, a basic smoke test runs to verify the app's core functions. But because of that sneaky little bug, the smoke test fails. Instantly, the GitHub Actions pipeline spots the failure and slams the brakes on the deployment.
Now, here is the critical pivot point of this entire architecture. In a normal setup, this is where the whole process dies and some poor developer gets an angry automated email. But in our self-healing workflow, the system does not stop. GitHub Actions automatically fires off a webhook, which basically alerts our automation platform to kick off the healing process.
Section 4. AI analysis and fix generation. The brain.
Okay, this is where our nervous system and our brain actually spring into action to process the error that just halted everything. The second that webhook fires, N8N takes over the orchestration. First, it uses secure repository secrets to authenticate with GitHub. Then it reaches right back in to automatically grab the exact failure logs from that busted smoke test. Finally, it bundles up those logs alongside the context of the recent code changes and ships them directly over to OpenAI's API.
I really want to pause on this quote from the source material for a second. Bridge the gap between DevOps and automation. Because honestly, that is precisely what N8N is doing here.
If we didn't have an orchestrator handling the secure fetching of the logs and managing those API payloads, the AI would be totally blind. It would have zero context. Init-N is absolutely the vital infrastructure making this whole magic trick possible.
Once that data crosses the bridge, OpenAI gets right to work. It analyzes the fetched logs and generates specific code fixes instantly. The AI actually reads the stack trace, pinpoints exactly where the node or express code failed that smoke test, and drafts a highly precise resolution. Think about that for a second. Not a single human being had to read one single line of an error log, and yet a fix was just engineered. It's wild.
And this brilliantly illustrates our final step. Section 5. Deploying the automated fix, the resolution.
Look, having an AI generate the perfect code is awesome, but it's pretty much useless if it's just sitting there in an API response payload, right? We have to get that code back into our project safely. So let's trace this final journey. N8 takes the code generated by OpenAI and executes a series of Git commands. It automatically creates a brand new isolated branch, pushes the AI-generated fixes up to it, automatically opens a pull request explaining exactly what the error was and how it fixed it, and then fires off an email to the team letting them know a fix is ready for review.
So, the code is fixed, the pull request is sitting there just waiting for a quick human approval, and the system is primed and ready for production deployment. But you know what the best part is? Because the system caught the error, analyzed it, and wrote the patch entirely on its own, developers can actually get a full night's sleep instead of fighting with broken builds till dawn.
Which really leaves us with this final, provocative question. Is manual debugging officially a thing of the past? Now, keeping a human in the loop for that final pull request approval is absolutely still a good idea. But the days of manually hunting through endless logs just to write boilerplate bug fixes, those days are rapidly coming to an end. By combining GitHub, N8N, and OpenAI, you can genuinely build a pipeline that heals itself. Thank you so much for joining me on this explainer, and I really hope this inspires you to go out and start building your own autonomous workflows.